Welcome back to AI Verdict. Today, we are diving deep into a quiet little embarrassment at the very heart of modern physics. It's a problem so strange, so profound, it forces us to ask a really fundamental question. Is the reality we experience even real when we're not looking? Let's get into it.
So it all starts right here with this secret that physicists don't really like to talk about in public. It's usually buried under layers of incredibly complex math. But the problem itself is actually pretty blunt, and it is very, very weird. It's like a fundamental crack in our whole understanding of the universe.
And boom, here it is. This is the core of it, laid out plain and simple. Now, this isn't some line from a philosophy book. This is the uncomfortable, unavoidable conclusion of our single most successful scientific theory ever, quantum mechanics. It's telling us that the world around us, the very fabric of existence, is somehow brought into being by the simple act of looking at it. Now, I know what you're thinking. This sounds like pure speculation, right? But here's the thing. The predictions that come from these bizarre quantum principles, they are so ridiculously accurate that almost all of our modern technology depends on them. Lasers, the computer you're watching this on, MRI machines, they all work because this weirdness is real.
Okay, so let's treat this like an investigation. And our first stop has to be the scene of the crime, the very heart of the quantum mystery itself.
So in the quantum world, a particle isn't just in one place at a time. It exists as this kind of haze of possibilities. It's here, it's there, it's basically everywhere it could possibly be, all at the same time. We call this superposition, and physicists, they map out this haze with a mathematical tool called the wave function, which basically tracks all the potential realities for that particle. And this is where things get really wild. Think about it like this. In our normal, everyday world, measurement is passive, right? A thermometer just reveals a temperature that was already there. But in the quantum world, the act of measuring something doesn't just reveal reality, it seems to create it. Before you look, it's not just that you don't know where the particle is, it's that it literally doesn't have a definite position. And this is the million-dollar question. It's called the measurement problem. So when we're not looking, this wave function of possibilities evolves perfectly smoothly. But the absolute instant we measure it, all those possibilities just collapse into one single definite reality. The theory is unbelievably good at predicting the odds, but it never, ever explains how or why this collapse actually happens. So if the act of measurement is the mystery, our investigation naturally has to turn to the one thing that seems to be causing it all: the observer. The physicist John von Neumann famously traced this whole chain of measurement. Okay, so the particle hits a detector. The detector triggers a result on a screen. Light from that screen enters your eye, and a signal travels to your brain. But here's the catch. According to the actual math of quantum mechanics, every physical link in that chain, the detector, the screen, even the neurons in your brain, they all just get tangled up with the particle. The whole system just gets stuck in a bigger and bigger and bigger superposition. So here's the crucial point. That physical chain, it never breaks on its own. The math says that even your brain is in this quantum haze of possibilities until the very last moment of actual awareness. This led von Neumann to a logical but deeply unsettling conclusion. The collapse has to be triggered by something non-physical. It has to be consciousness itself. And this is where it gets even weirder, thanks to a thought experiment from Eugene Wigner. Imagine your friend is in a sealed lab and they measure a particle. Okay, to them, the result is clear. It's definite. But to you, standing outside the lab, your friend and the particle are now just one big quantum system existing in a superposition of all possible outcomes. So did reality collapse when your friend saw it, or does it wait until you find out? It's a paradox that suggests either reality is totally subjective, or that your friend can literally exist in two states at once. This massive philosophical puzzle led some scientists to start looking for a physical answer. I mean, if consciousness is the key, then maybe, just maybe, it's because the brain itself is operating as a quantum machine. And this brings us to the or theory pioneered by two brilliant minds. On one side, you have the mathematician Roger Penrose. He argued that human understanding does things that no classical computer ever could, meaning our brains have to be more than just simple algorithms. On the other side, you have the anesthesiologist Stuart Hameroff. He identified a possible location for this quantum action,
these tiny crystal-like structures inside our neurons called microtubules. So Penrose proposed a way out of the whole observer mess. He argued that these superpositions, these quantum hazes, are actually unstable. When a system gets big enough, it creates a tiny little blister in the fabric of space-time itself, which then quickly collapses back into a single state all on its own. He called it objective reduction, no observer needed. And then he made a radical proposal. Each one of these physical collapses is a single moment of conscious experience.
So how often is this happening inside our brains? The theory calculates it's about 40 times per second. And that number is no accident. It's almost exactly the frequency where individual moments start to blur together, creating a smooth, continuous stream of awareness, kind of like how the individual frames of a movie create the illusion of seamless motion. But for decades, this entire idea faced a huge scientific roadblock. I mean, how could these incredibly delicate quantum effects possibly survive inside the messy environment of a human brain? This was the classic objection, the one everyone pointed to. We all know quantum effects are fragile. In a lab, you need temperatures near absolute zero to see them. The brain, on the other hand, is a warm, wet, chaotic, and electrically noisy place. In theory, any quantum state in there should just fall apart almost instantly. But it turns out biology is way cleverer than we gave it credit for. The new field of quantum biology has discovered that nature uses these quantum tricks all the time. We now know that plants use quantum coherence at room temperature to do photosynthesis efficiently. And new research even suggests these microtubules might support something called superradiance, where tiny quantum bits all synchronize and act like one big, stable quantum system. It looks like the brain might be perfectly evolved to live right on that razor's edge between the classical and the quantum worlds. Okay, so let's pause for a second, because if the brain really is a quantum machine, the implications just explode outwards, from the little space inside our skull to the entire nature of the cosmos itself. This brings us to probably the strangest concept in all of science, quantum entanglement. When two particles interact, they can become linked in this bizarre way. If you measure one, you instantly influence the other, no matter how far apart they are, even if they're on opposite sides of the galaxy. Einstein absolutely hated this. He called it spooky action at a distance. But guess what? Decades of experiments have proven it is 100% real. It's a fundamental feature of our universe. So let's connect the dots. If our consciousness depends on these same entangled quantum processes, then it must participate in the same non-local web that underlies all of physical reality. This isn't just a poetic idea, it's a structural claim. Your mind might not be as isolated as you think it is. This paints a completely radical new picture of reality. At the deepest, most fundamental level, the universe isn't a collection of separate little things. It's a single, unified web of relationships. And consciousness, in this picture, isn't just some passive spectator watching the show, it's actually woven directly into the fabric of the web itself. And that leads to a pretty mind-blowing possibility. The feeling of being a single, solid self located somewhere behind your eyes. What if that's just a kind of user interface? A simplified, useful illusion that helps us navigate a reality that is fundamentally interconnected and non-local, without our brains being completely overwhelmed by it all. And that leaves us with one final, totally destabilizing thought. If consciousness is part of the actual mechanism by which the universe becomes real and definite, then it's probably not just some random evolutionary accident. It might be one of the ways the universe even gets to exist at all. So the question isn't just, what is consciousness? But maybe, just maybe, is the universe observing itself through you?